Hey guys, so welcome to the malware tricks course. Again, we're gonna be playing with other scenario here. First of all, we're gonna be dealing with some anti-reversing techniques. In this case, it's just a simple one that I want to make sure that you guys understand. Okay, so here I'm gonna be using a sample from a public challenge prepared by Flair team from Mandiant, and that challenge included some anti-reversing and anti-virtual machine techniques that it is pretty useful for us to understand all those different techniques in one single binary. Okay, so for educational purposes I choose that one so that you can understand it, all the techniques. So here we are in the entry point, Control E, as you remember, in IDA Pro, double click, here we are, and then as usual we can use this graph overview to go quickly down. We need to find the main entry point. A clue is you find the get command line, keep going down. Eventually you will find IDA saying this is the end of the function chunk for start, and normally it can be different based on the compiler, but normally you will find a push EAX and then two different pushes of memory, and in this case here is our main entry point. We'll double click on it and we are here into the main instructions. Okay, so these different functions are gonna be the anti-virtual machine techniques. Okay, but here I'm gonna show you an anti-reversing technique. So basically anti-reversing means that the malware authors wants you to be confused about the code so that you don't understand properly and you won't be able to analyze it. Like in this case, it says call near this number in red, which points to nowhere, right? So how come we can analyze that code if we don't know where it's pointing to? But here is the trick, guys. If you see right before, you can see that it is saying go to 41B0F plus 4. If you do the math is gonna be 41B13. That destination should be here in the left side, but it is not, right? You cannot see the 41B13. That's because IDA got confused and was not able to translate it properly. So what you need to do is you need to go to that red thing, which is right here, put the cursor there and push press the letter U, which means undefine the instruction. When you click OK. When you undefine it, you can see that now you can see the offset 41B13, right? Right there, we put the cursor and we press the C. Before pressing the C, you can see that that specific offset, now IDA recognize it here in the jump and now understood that that's the proper offset. Okay, so we come back here, we press the letter C, which means convert to code. We say yes, and we got our code fixed. You see, and now we have this call, which is perfectly accessible. It's a function that we can find. Okay, guys, so this is very important for us to understand. There are other tricks, but basically with this one, just keep in mind, as I said, if you see something in red color in IDA, that means there were some errors parsing it, and in this case, go to that specific offset, undefine it, and then put C on the offset that it is expected. In this case was 1B13. Okay, guys, so that's simple. It's a simple trick, so that you can use to fix your code. Okay guys, so let's talk about, let me close this one. Let's talk about now some anti-virtual machine or anti-VM techniques. Okay, so we have here the same sample, but I label it so that you guys can easily understand what is the purpose of every function. So let's start with the first one. So basically, anti-VM techniques, mainly what is gonna be doing the malware authors, they wanna do some checks to know if, or to detect if the malware is being analyzed through a virtual machine or through a debugger, right? We can have different ways to check if it is running through a virtual machine or through a debugger. In this case, we have isDebugger, right? So let's check this first technique. This is pretty simple. We double click on it. You can see that it is gonna use a well-known API, which is called isDebuggerPresent. As you remember, we know it is an API because it is in pink color, so you don't need to reverse it. If you Google it, basically it's gonna go and check if there is a debugger running. If there is a debugger running the sample that you are analyzing. If that's the case, it's gonna return 1. Okay, but if there is no debugger, it's gonna return 0. So as you might guess, if you wanna trick the malware into thinking there is no debugger, you need to return 0, right? Or you need to tell the malware that it is a 0 in the return so that it thinks there is no debugger. Now, a little bit of context, guys. This specific challenge, what it is doing is that if there is a debugger present, it's gonna check here the result. As you remember, the result is gonna come in EAX, and it's gonna check if it is 0. Test EAX means is EAX 0. Then if it is the case, it's gonna go to this brand, which means no debugger, right? I press the semicolon, by the way, to put a comment. There is no debugger because it's 0, but if doesn't come here, that means go to the other branch, which means debugger found. Okay, and basically this challenge, what it is doing is, if there is a debugger found, it's gonna go to this branch, to the left one, and it's gonna use an initialization value that is gonna generate some output. Obviously, in the right side is a different initialization value, which means the output is gonna be different, right? The output is gonna be a binary, by the way, but the point is that if you don't trick the malware into thinking it's not running under a debugger, the output is not gonna be the one as expected, and therefore the challenge is not gonna be completed. Okay, but don't worry about those instructions. We just wanna practice how we can patch or bypass the anti-debugging checks in this case. Okay, so as usual, let's test this in the debugger. So we double click in our Immunity Debugger. We go and open that sample. Okay, we maximize it, and then we're gonna jump into that instruction. As you remember, this instruction is pointing to 40.10.30. 40 is the base address. In this case, the base address is 42. Sorry, excuse me, is D4. Different base address, but the same 1030 relative address. So we go to the bottom, we say base pointer 0x D4, which is the base address, and then 1030. We press enter. Then we put the letter G to say go, and we click enter. We jump here, which is the entry point that I previously put an entry point, so that's the reason it is stopping here. Is you wanna see the entry points, you do Alt B, and you can see that I had already this entry point. Let me just remove them to avoid confusions. And I have another one here, and we just leave that one. Okay, we click on letter C to return to the code, and again we go and press the letter actually we just press the button play here, and we jump into the function, right? So let me go through it. It's going to say push, and then isDebuggerPresent. Check the value in EAX. It is 1, right? It is 1 because there is a debugger present. As you can see, we are running through a debugger. And here it comes the different ways to bypass this. The first one and easiest one is, since we know that it must be 0, we just right click on it right after running the instruction, and we say 0. It changes it to 0, which means when it comes to the test EAX, which means is EAX 0, check the 0 flag is going to be set, which is, it's already set, so it didn't change. And then it says jump is going to be taken, and as I said before, it's going to go to a branch which is going to do some initialization, but the main point is that we bypass the check. Okay, so that's one option. A second option, guys, and let me go here in order to check the second option is, I'm gonna restart the debugger by pressing into this button. Okay, we say yes. We already have our breakpoint set, so we just press play. So we are back, and here what I'm gonna do is this, guys. I'm gonna go over it. It says 1 as expected, and because we did a change, but it's not a permanent change. It's just within the debugger session. Once we restart the process, everything is lost. That's one of the disadvantages. Okay, so we're gonna put a permanent solution here. So we go to move XOR test EAX, right? When it says test EAX, the 0 flag is clear because it's not 0, right? And then this guy is not gonna be taken, but we want it to be taken, right? As we discussed. So what we can do quickly is to patch this jump. Double click on it. We do the opposite. Jump equal, we set jump not equal. Assemble. That's simple. We just press put the cursor into that specific instruction. It doesn't matter actually, but it's just a best practice. And then you right click into that specific window, and actually that's the reason you go and click here, because depending on the function, because we have 4 functions, sorry, on the window we have 4 windows in the debugger, right? Depending on the window, it has different submenu. Okay, so for example here, if I click here and then click right click, it's gonna give me this menu. But if I go here to the registers and click also on them and then right click, you can see it is a different menu. That's the reason you need to make sure you are into the assembly code window. Okay, so we right click on them and we say copy to executable selection. Okay, selection means where we are located, but let me close it. It says no. Okay, you can also say here copy to executable all modifications. You say yeah, copy all. In case you patch many other instructions, is you just gonna copy everything to the new executable. In this case was just one instruction, so it doesn't matter, but so that you know. Then in this window again, we say save file, and we can put A95 patched. Okay, and let's just open the new one. We say open patch 1. Yes, I want to terminate the current one. Here we have now a different base address, which is 0120, but it is the same relative address of the function. So I'm gonna show you a different way to reach that function now. Instead of going to the bottom and put the command BP, we're gonna say in this window, we click on there and then Control G is gonna say enter expression to follow. We say the base address 0120 and then 1030, which is the relative address. We reach again here the function. We press F2 and then play, and we just jump there right away. Okay, now here we're gonna do the jump. It is 1, because there is a debugger. It's gonna say, hey, is there a debugger running? In other words, is EX 0? It says no, it's not 0. So, but as you remember, we patch it. So basically, we really want to take the jump, right? You remember? We really want to take the jump. So in this case, since we changed the logic of the jump, we take it, jump is taken, and again, we bypass it, but this time in a permanent way. Let me tell you something quickly. In the right side, you can see that there is no registers. Sometimes the debugger changed this view. I don't know why, but you just click here and you will get it back. Okay. Okay, so that's pretty much it, guys, with the isDebugger API. So you see how you can change it permanently or how you can change it through the session so that you can bypass this check. Okay, so let's talk about the second function. Okay, so we come here to the main options. We go to the PEB.BeingDebugged. Okay, so actually the PEB.BeingDebugged function, if we double click on it, it's gonna do exactly the same as the previous one, which was the API isDebuggerPresent, but instead of calling the API, it's gonna access what is called the process environment block, which is basically, or PEB, which is basically all the information related to this process. And one of the main options or the information within this block, it is how can I tell you, is the value called isDebuggerPresent. Okay, the name of that value is called PEB.BeingDebugged, which means if it is 1, it is a debugger present. If it is 0, there is no debugger present. How you can access the PEB? Here is the trick, guys. Every time you see in IDA FS:30, that means it is accessing the process environment block. So let's document it here. PEB. Okay, it is passed to EAX, and then you can see here that from there is gonna add two more positions in memory, and that is gonna be compared with 1. In other words, it is accessing the process environment block, or PEB, is going to the value which is at offset 2, and it's gonna compare it with 1. Let me show you what is exactly the content of that value. For that, I'm gonna be using WinDebug, which is another debugger. So I just click window R, and assuming that the path of the WinDebugger is already into the path environment variable. And let me show you the other one. I don't want you to get confused. So I'm gonna click window bottom and break. Then we go to advanced system settings, environment variables, and here is where you have the path environment. Okay, that path environment, if here you have added your path to WinDebug, then you can just call it via shortcuts. You can see here I have all the different tools, and this one, you see this one, program files, Windows Kits, 8.1 debuggers, x86 is the path for my WinDebug. Okay, because of that reason, I can easily say window run, and then here I just put the name WinDebug. Okay guys, now here let me open executable. We open this guy again. Okay, don't worry about anything here. It is very useful to use WinDebug because it can give you a lot of information about structures, internal Windows structures that definitely you cannot, or it is difficult to access within the debugger. WinDebug is made by Microsoft, so it has more context about the structures inside the operating system. So if you just do bang PEB enter, it's gonna print all the content of the process environment block. Okay, we start from here. It's gonna say, okay, it is located at this address, and check this. If you remember in IDA Pro, it was saying PEB plus 2, right? Okay, see, this is 1. Sorry, this is 0. This is 1. And this is 2. Okay, and that value is called being debugged. If it is yes or 1, that means there is a debugger running the sample. If it is 0, that means there is no debugger. That's exactly what is being checked in the function. As we know, the value is 1 because it is running through a debugger, right? So let's check it with Immunity Debugger, right? Now that we saw, by the way, before going there, feel free to go to all the different values into the process environment block. This is very important. It is all the modules loaded by that specific program. Okay, here is the path of your program also. And finally, the environment variables. Okay guys, so let's go now to the Immunity Debugger, and let's try to go let's try to check what is the value, right? So I am here in the debugger, which was the first function. I'm just gonna put a breakpoint into the return just to get out of this function quickly. Okay, I press play, I jump into that instruction. Now I press F7, and finally I am in the function 10C0, which it is exactly this one. Okay, here, as I said, it's gonna move PEB to EAX, then it's gonna say +2, and that value should be 1. Let's see if that's the case. F7. Okay, here PEB to EAX, compare with 1, and you can see that here the debugger is printing us the value in advance, which is 1, as expected. Again, in this case it's more graphic, the problem, because if we compare it, we see that the jump is taken because it is 1, and you can see that the unacceptable string is going to be used to do some obfuscation, sorry, some calculation of the binary. But we want to jump to the second branch, which is using the glove string. here in the debugger is hard to see, but as usual in IDA you can see clearly that there are two branches, and basically this one is the wrong one and this is the right one. Okay, we saw that when it compares with 1, it says yeah, it is equal to 1, and then it didn't put a 0 in bar 4. Let me put an N, and then I'm gonna put a flag label, and this flag label, you can see that it was initialized with 1 here, and then since this turns out to be 1 here, the jump was taken and this flag was never set to 0. Therefore, when it comes here and said, hey, are you 0? You said, no, I'm not 0. It comes to unacceptable. But we want it to come to this branch. Okay, so I teach you how you can fix it, right? I teach you that you can change this jump 0 logic. That's one option, but let me now teach you a different way, which is a fancy one. Let's use the debugger to do the change. Okay, so in order to do that, let me restart this program again so that we can run it. Since we already have the breakpoint, we just click on play. This is the first one that we set in the first function. We don't want to jump here. We remove those breakpoints by going to the offset and pressing F2, and then we click on play again. Ouch, sorry guys, I didn't put out the breakpoint. Let me restart it quickly. We go to this specific address, which is 10C0, Control G, 10C0. Okay, we are right there. F2, and now enter. Okay, so we are right there. Okay, so now we, as you know, the value of being debugged inside the process environment block is 1. So let's use Immunity Debugger to patch it, which is pretty cool. So we go here to this icon, which is the prompt of the debugger. Here we can interact with the API. Okay, so the API, what we can do is we can say something like im, which is the object related to the debugger in order to access the APIs, and then we say im dot read memory. That's a proper syntax and actually is case aware, so make sure to put it in the right case. Then inside the parentheses we say im dot get PEB address, which means get the PEB address plus 2, as you know, and just get one value. Okay, we press enter. It was my mistake. I forgot to put the closing parentheses. Let me do it again. I just copy, paste, and then here I said comma 1, and then I close the parentheses. Okay, I press enter, and you can see that it is saying, hey, the value right now is 1, as we know, right? It is 1 because there is a debugger. So let's patch it. The way you can patch it is im write memory, okay, where into the get PEB address, right, plus 2, and here we're gonna put the value to overwrite, in this case with 0. Okay, We press enter and it returns 1, which means the operation was executed successfully. So let's now print the content of this guy to make sure that we did the change properly. Now it's 0, guys. Okay, so if we come now to the debugger and start running it again, it will go here and it's gonna say, hey, give me the PEB in EAX. Now, what is the value of EAX plus 2? You can see that it says it's 0. So we properly patch it, and therefore the jump is not taken, and we go to the branch that we wanted to go, right? That's pretty cool, right? So we bypass it, but by using the Immunity Debugger API in order to patch properly this specific check.